Hello everyone, I am Dr. Samyukta S, Assistant Professor, Department of ECE at SJBIT. In this video, I am going to explain you about the flip-flops. Okay, so what are flip-flops, what are the types, and what are the application areas of flip-flops. Okay, a flip-flop is a digital electronic circuit used to store one bit of binary information. It has two stable states, logic 0 and logic 1. Hence, it is called a bistable multivibrator. Flip-flops are the basic memory elements used in digital systems. So, the application of this flip-flops are, it is used in registers, counters, memory devices, shift registers, and it is also used in digital clocks, frequency division, sequential circuits, etc. See, a combinational circuits depends only on present input, whereas the sequential circuits depends on present input and the previous output. Here the flip-flop provides the memory. As I told, a flip-flop stores one binary digit. Okay, so here I have written the circuit here, which consists of two NOT gates where the outputs are Q and Q bar. For example, if Q is equal to 1, the flip-flop remains 1 until another input changes it. If Q is equal to 0, it remains 0. So it stores one bit and it has two outputs, that is Q, normal output, and Q bar, that is a complement output. If Q is equal to 1, then Q bar is equal to 0. If Q is equal to 0, then Q bar is equal to 1 here. So as we all know, there are different types of flip-flops, that is SR flip-flops, JK flip-flop, T flip-flop, D flip-flop, etc. Here I have considered the SR flip-flop. Here the SR stands for set and reset. It is having two inputs S and R and two outputs, that is Q and Q bar. It is the simplest flip-flop, but here in the diagram the inputs are represented by A and B and the outputs are represented by C and D here. Okay, if you see the truth table of this SR flip-flop, here you can see, here I have considered the clocked flip-flop. Here clocked SR flip-flop. Here if S is equal to 0 and R is equal to 0, there won't be any changes. For example, if Q is equal to 1, after input Q remains 1. If S is equal to 1 and R is equal to 0, set operation is going to take place so that the output becomes 1. If S is equal to 0 and R is equal to 1, then reset operation will going to take place so that the output will become 0. If S is equal to 1 and R is equal to 1, both output becomes the same, violating the complementary relationship, and this condition is not allowed here. Okay, so here you can see the circuit symbol truth table as well as the circuit diagram of the clocked SR flip-flop circuit. So why clock means normal SR flip-flops respond immediately to input changes. In digital system, we want changes only at specific times. This timing is controlled by the clock. Okay, so when clock is equal to 0, the flip-flop ignores S and R. Output remains unchanged here. Okay, so when clock is equal to 1, the flip-flop responds to S and R here. Okay, the same thing here you can see in the truth table. If clock is equal to 0 and irrespective of any inputs, there will be a no change condition will going to exist. If clock is equal to 1 and if the inputs are 1 0, then the set operation takes place. And if the clock is equal to 1 and the inputs are 0 1, then the reset operation will going to take place. And if clock is equal to 1 and when both the inputs are high, then it is an invalid condition. Okay, so the advantage of this clock ASR flip-flop is it controls the operation and there will be a less chance of unwanted output changes. Okay, so next is the clock ASR flip-flop with reset condition here. So apart from clock set and reset, an additional reset signal is provided. The purpose is to immediately clear the output whenever reset becomes active. That is, whenever reset becomes active, Q is equal to 0 regardless of the clock. This is called an asynchronous reset. Here you can see the circuit symbol and the truth table and the circuit diagram of this clock SR flip-flop circuit. Next is edge triggered flip-flop. See, the problem with level triggering is if the clock stays high for a long time, the output may change multiple times. To avoid this, edge triggering is used. Okay, the flip-flop changes state only at the instant the clock changes. Okay, so there are two edges here, positive edge and the negative edge. Positive edge is called as a rising edge, whereas the negative edge is called as a falling edge here. Okay, so the benefits of this edge triggering flip-flops are that there will be an accurate timing in this type of flip-flop and it is reliable for the operation and it prevents repeated changes during one clock pulses. So as I've told, there are two edge triggering flip-flops, positive edge triggering and negative edge triggering. Here you can see the circuit symbol as well as the truth table of the positive edge triggering flip-flop. So this positive edge triggering flip-flop changes only on the rising edge of the clock. See here. So as an example, I have considered the D flip-flop which is having only one input, that is D, and one clock input and two outputs, that is Q and Q bar here. Okay. So when clock changes from 0 to 1, only at this instant does the flip-flop reads the input. Example, initially Q is equal to 0 and if clock rises from 0 to 1, if D is equal to 1, then Q becomes 1. So after that, even if D changes, Q remains unchanged until the next rising edge. Okay, so next is the negative edge triggered flip-flop. So here as an example, I have considered the JK flip-flop here. So it is having two input J and K and two output Q and Q bar. Along with two inputs J and K, we have a clock input here. You can see. So when you observe the truth table here, when clock changes from 1 to 0, only during this falling edge the flip-flops updates its output. So initially Q is equal to 1, clock falls from 1 to 0. If D is equal to 0, then Q becomes 0. So after that, changes in D have no effect until the next falling edge. Okay. So the application of the negative edge triggering flip-flop is that it is used in synchronous counters, it is used in shift registers and timing circuits, and it is also used in the microprocessor. So coming to the applications of the positive edge trigger flip-flops. So those are used in registers, counters, processors, and in the memory systems. Okay, so this is about the flip-flops and the positive and the negative edge trigger flip-flop. Thank you.